Hi everyone, welcome back to another video in the motion series, this time on work, where the work's being done by angled forces. Now when I first saw a question like this, I freaked out a little bit, because it's not quite clear, according to the formula, work equals force times distance, what I'm supposed to do. If I say had a 50 kilogram box here, being pulled on a slant like so, at an angle of 60 degrees by 300 newtons. So even though the box I do feel is going to accelerate in that direction there, it's not clear whether I'm supposed to multiply 2 by 300, as would be implied by the formula up there, or I'm supposed to work a few other things out. Let's look at the correct method of working out this question. So the goal is going to be to find the final kinetic energy and the final velocity. Let's assume for now the box starts at rest, so its initial kinetic energy is a half m velocity squared, initial velocity given by u here, and v here is 0, so kinetic energy initial is equal to 0. We can figure out whether this box is going to be lifted off the surface into the air or it's going to slide along the ground by figuring out whether the weight force on this box is strong enough to hold it down. So the weight force is equal to mg, which is equal to 50 times 10, or 500 newtons. Then we've got this driving force pulling up, and we've got a normal force acting on the from the ground on the object, normal force there. If this force is too big, the normal force will shrink to 0 and the box will fly off the surface. If this force is too small, the normal force will step up and act to counter the gravity force, keeping the object from having any net force in the vertical direction. We covered a question like this when we did balancing forces. To find out how big the normal force is, first we have to figure out the horizontal and vertical components of this force here. So it has horizontal component there, vertical component there, but I'm going to draw that vertical component over here. The horizontal component of the force is cos 60 degrees 300, and the vertical component is sine 60 degrees 300, which is equal to root 3 on 2 times 300, or 259 newtons. So there's 259 newtons worth of upward force being applied by that slanted force here. And that means if the object really is not accelerating up or down, the normal force is going to make up the rest of that 500 newtons, which this force fails to make up. So 500 take away 259, 241. Even if this is confusing, the number one thing to take away is as long as the weight force, so here 500 newtons, is larger than the vertical component of this force, the object will stay on the ground. Now though, we can look at the horizontal component of that force there, because the horizontal component of this force is what is doing all the work. So the horizontal component was cos 60 degrees times 300, or in other words, 1/2 times 300, or 150 newtons. This is the component of the driving force which is acting in the same direction as the motion of the box, which is 2 meters to the right. Since this is the component acting in the direction of the motion, this is what we take as the F in work equals F times D. So we can say the work done by this force on this box over this distance is equal to force times distance, but we only take the component of this force acting in this direction, which is 150. So it's 150 times 2 meters or 300 joules. That means by the time it gets to this point here, its final kinetic energy will be equal to the kinetic energy it had at the start, plus the change in kinetic energy, which is also the work. So the final kinetic energy is 0 plus 300, or 300 joules. The fact that we had a force of 300 newtons on a slant like that does not mean we put the number 300 into our formula here. Instead, we figured out the horizontal component of that force. So even though we are pulling upwards at 300 newtons, we end up with a box which has just as much velocity as if we'd simply applied, and ignoring all other forces here, simply applied a force of 150 newtons that way. We have the same result. Finding out the final velocity, well, we say 1/2 mv squared is equal to kinetic energy. So 1/2 50 v squared is equal to 300. V squared is equal to 2 times 300 over 50. V is equal to the square root of 2 times 300 over 50, which is equal to around about 3.4641. So we'll just say 3.5 meters per second, around about. So far in the videos, we've only done questions in which the object started from rest. Let's do a question now. We'll actually just alter this question so that the initial velocity was 2 meters per second. So u is equal to 2 meters per second. And we'll figure out the final velocity now. It won't be 3.5. So taking away all this. The work done on this box is the same, because work is simply the force in the direction of motion times the displacement or the distance. So the work is still 300 joules. And since that's the only force acting on this object, that'll also be equal to the change in kinetic energy. But the final kinetic energy is equal to the initial kinetic energy plus the change. Get used to that. So another way of writing that is the change in kinetic energy is equal to EKF take EKI. That's just that rearranged. And the initial kinetic energy, it was 0 in the previous question, but in this question, since there is some starting initial velocity that's not 0, the initial kinetic energy is going to be 1/2 50 times 2 squared, and then we add on our 300 joules for the change in kinetic energy. So simplifying this down, that's 1/2 times 50 times 4, that's 2 times 50, 100 joules, plus 300 joules, 400 joules. So whereas before, the box which had started at rest, by the time it had been accelerated 2 meters by that 150 Newton force in this direction, had 300 joules of energy, the box which starts with a little bit of motion, and therefore a little bit of kinetic energy, has 400 joules of kinetic energy by the time it's been accelerated that 2 meters. So that final kinetic energy we know is equal to 1/2 mv squared, getting v by itself, 2ek on m, take the square root equals v. We get the square root of 2 times 400 divided by 50. That equals 2 times 400, 800 divided by 50, the square root of 16, or 4 meters per second. Notice something interesting. In the first question we did here, the object that started at rest reached about 3.5 meters per second of speed, or velocity, by the time it reached this location. The object that started at 2 meters per second only reached 4 meters per second. So even though it started with an extra 2 meters per second, it only ended up with an extra half a meter per second of velocity. This is a quirk of the fact that kinetic energy is related to v squared and not linearly like v. I've seen many people make the mistake of saying, okay, that first box accelerated 3.5 meters per second from 0, so if it starts at 2, that'll be 2 plus 3.5, which will end up 5.5 meters per second of final velocity. That's not the way you can do it. You've got to go through and add up the initial kinetic energy to the change, and then work backwards from there to find that velocity.